Okay, now, there's one more kind of problem to look at, and that is solving logarithmic equations. And then we'll take a break before we get started on section 4.05 on growth and decay. All right? Now, I'd like to do as an example problem number, let's see. I'd like to do number 24. Number 24, this is continuing section 4.04. 4.04. And it says the log base 3 of x plus the log base 3 of x plus 8 is equal to 2. Now what? Well, before we do anything else, we need to get this log pulled together into a single logarithm.
Right.
Pull the logarithms together into a single logarithm. What can we do there? Log base 3. Now this is a sum of two logarithms. So you can make it the log of the product, right?
Yeah.
The x times the x plus 8 is equal to 2. Okay, is equal to 2. Now that I've got it into a single logarithm, what I want to do is I want to make it exponential form instead of logarithmic form. So what would you do to change it to exponential form? 3 to the second power, 3 to the second power equals this, right? 3 to the second power, 3, let me use the right color, 3 raised to the second power equals to this product, which is x times x plus 8. What is x times x plus 8? Can we go ahead and multiply that out? What would it be? X squared plus 8x. X squared plus 8x. Any questions on that? Okay, yeah. Yeah, we can also do the 3 squared, which would be 9. Okay? So that 3 squared is 9, actually. So it equals to 9. Now let's get it equal to 0. What would you do to make it equal to 0? 0 equals what? X squared plus 8x, and then what? Minus 9. All right? Minus 9, that's going to equal 0. And your first attempt to solve this would be to try to factor it, right? Well, we changed out from logarithmic notation to exponential notation. We changed from log base 3 of something equals to 2 to 3 to the second power equals that. That changes it out of logarithmic notation into exponential notation. Okay? Now I need to factor this. X, 9 and 1, right? 9 plus 9 minus 1. So we get equals to 0. So therefore, x equals to negative 9, or x equals to 1. Now, at first glance, you probably think there are two answers to this, right? Negative 9 and 1. But there's a problem, and that is that you cannot take the log of a negative. We did that before, didn't we? Take the log of a negative 9 and see what you get with your calculator. Give your calculator a negative 9 and try to take the log of negative 9.
So that answer is rejected.
It won't do it, will it? There is no such thing as a log of a negative 9. So this answer is rejected. And because you can't have, see, if x is negative 9, that means that this is negative 9 up here, and you have the log base 3 of negative 9. That can't be. You see, it's not x being negative that I object to. I don't mind if x is negative, but I can't have the log of a negative number. I can't have a log here of a negative. I can't have a log here of a negative. Any place that gives you a log of a negative would not be allowed. So this is rejected. And the answer 1, there's one word. Log of 1, you can have log of 1, can't you? Can you have the log of 1 plus 8? That would be log of 9. Yes, you can do that. So that's acceptable. X equals 1 would be the acceptable answer to that.
So how would you do log 3 of 1?
All right, how would you do log base 3 of 1? You'd have to say log base 3 of 1. Let's just pretend we don't know what it is. X. And then what would you have?
Log 3 to the x.
3 to the x equals what? 3 to the what equals 1? 3 to the 0 equals 1. I'd like to do one more problem. Which one do I want to do here? How about number 30? Number 30. Log base 3 of x minus 2 equals to log base 3 of x plus 2 plus 2. All right? Now, I've got a problem here. I've got logs on both sides of the equation. I want to get the logs on the same side of the equation. What would it be? Log base 3 of x minus 2. And then what? Minus the log base 3 of x plus 2 is equal to 2. Now what? Well, before we go to exponential form, we got to do one more step. We got a log minus a log, so we got to put that into a single logarithm. So that would be log base 3 of what? X minus 2 over, because it's subtracting logarithms, you have to say over x plus 2, and that equals 2. Now we translate back into exponential notation, which would be what? 3 to the second is equal to x minus 2 over x plus 2. 3 to the second equals this. Okay? And now 3 to the second, of course, is 9. 9 means like 9 over 1. Multiply both sides by the common denominator, or some people say cross multiply. And what do you have? X minus 2 equals to 9 times the quantity x plus 2, right? Which would give you the equation. I'm running out of room, I'm running out of time. X minus 2 equals 9x plus 18. Now what? Subtract 9x from both, just plain linear equation now. Subtract 9x from both sides. And that would give you negative 8x minus 2 equals 18. Add 2 to both sides. Negative 8x equals to 20. So therefore x equals negative 20 divided by 8. Reduce it to negative, divide out of 4, 5 halves. Negative 5 halves. Okay? Any questions on that? All right. I think that's all for now. I think we'll take a break, and we'll finish up 4.05, growth and decay, in a few minutes. All right? Thank you.